So, as Toby said, my name is Sarah Goff-Dupont. I'm in the marketing group at Atlassian. I work very closely with the developer tools, so that's things like Stash, Bitbucket, Bamboo, Fisheye, Crucible, Clover, and SourceTree. But I work most closely with Bamboo, and the reason for that is because before I got into marketing, I was a test automation engineer. I sort of grew up in QA and spent the last several years of my QA career as a test automator. So I get really excited about continuous integration because for me in my work life, it was like a whole new world when I learned about test automation. And I saw what a powerful difference it made in the teams that I was working with. So I get really excited about everything automated, everything agile, and I think that when you add Git into the mix, you get an especially powerful combination. And so that's what I'm going to be talking about today. I'll share with you some of the things that Atlassian teams have learned about doing CI and using Git as your repository management system. So, actually, who is using Git already? Okay, maybe about 2/3 of the room. Okay, how about who's not? Okay, so like maybe 3/4 of the room is with Git. Okay, so since there are some people who aren't using it yet, I'll go through just a brief explanation of why I think it's really great for it to use with it in a team setting. And then we'll get into the continuous integration stuff. I'll talk a little bit about how your CI system and your Git repository can sort of talk to each other and play nicely together. Then we'll talk about feature branches, which of course is probably the thing that people get the most interested in when you're talking about CI and Git. And then I'll end with some Git hooks that you can use to sort of make your CI system a little bit stronger. Wait, nope, there we go. Okay, so who here works on a team of software makers? Anybody just developing software all on your own? Right, exactly, exactly. So the lone coder is not the way software is built, at least not anymore. And there's a really good reason for that. When you work as a team, you get different backgrounds and different ways of thinking about problems and just different experiences. And when you bring those different ways of thinking, when you bring that to bear on whatever problem that you're trying to solve, you end up with better software. It tends to be of higher quality, it tends to be more maintainable, and ultimately usually serves the user better because you've got all those different brains in the room. But we also know that working as a team can be really messy. You're trying to figure out who is doing what and not step on each other's toes, and it can get messy. But the good news is that Git has a really, really great facility for branching and merging, which makes cleaning up the mess or actually avoiding the mess fairly easy. So with a branch and merge workflow, you can divide up pieces of a project, probably by user story or what have you, and then take those pieces of individual work and do them down on a feature branch. And that way, you can make as much mess as you want on your feature branch, and the people sitting next to you don't have to worry about that. You're not screwing them over, which is great. And then at the end, you merge all that work back up into the master branch, and it makes it very easy to see what work, which user stories or bug fixes have been completed. Because as soon as you see that merge commit coming into master, you know, oh, that bug is done. That's ready to release. Awesome. So it's really helpful for everybody on the development team, as well as project stakeholders like your product manager or perhaps your release engineer, to understand what is ready to ship out to customers. So Git helps you divide and conquer. Now you may be thinking, well, SVN and Perforce and ClearCase and CSV, they do branching. Yes, they do. But let's talk about branching's evil twin, the merge. So SVN and traditional version control systems are simply not that great at keeping track of different versions of files that live on different branches. So when it comes time to merge those files together, the version control system has to stop and ask you for directions a lot. Do you want their chunk? Do you want their code or your code? What do I do here? So merging becomes a very painful process. It's very labor intensive and very expensive. And so teams end up doing things like they do code freezes so that the person performing the merge doesn't get interrupted by new changes coming in. And code freezes are really expensive. It's very unproductive time. So then you start instituting like administrative controls that prevent people from making branches in the first place. Which is all well and good. No, it's not all well and good. Actually, what happens is that everybody is piling every little change onto the main code line, onto main or trunk or whatever you call it. And that makes that code line very unstable. The build is often broken because tests break, which is a natural part of development. You're supposed to break tests. It's just that you're also supposed to fix them right away. Anyway, the main code line becomes very unstable, so it's unreliable in terms of making a releasable build from. It's even hard to just figure out if there's a test broken or if there's 30 tests broken in the build. It's very difficult to figure out why that is because you have changes coming in from 5, 6, 10 team members. But with Git, however, those things don't happen. Because with Git, branching and merging is very easy. Git is actually really good at keeping track of different versions of files that live on different branches. So it's almost as if it has like a built-in GPS that it can use to sort of triangulate your changes, another person's changes, and then the common ancestor of the file that you're working on. So the upshot is that Git doesn't have to stop and ask you for directions when you're merging. And that makes merging really, really easy and fast. So you are free to exploit the power of branch and merge workflows in a way that you just don't. What you could with SVN, but really you just don't. So every team at Atlassian now uses Git, and we're so excited about feature branching that we've taken to creating a feature branch for every single issue that we work on. So if it's a user story, a bug fix, a refactoring task, it doesn't matter. If there's code being changed and it's tracked in Jira, and if there's code being changed, it better be tracked in Jira, right? It gets its own branch. So for example, we have 775 branches in the Jira code base. Now, keep in mind that Jira is made up of a lot of small component repositories, but still, 775 is a big number. So I just use that to demonstrate that we are serious about this branching thing. So this is the basic workflow that we use. Development branches or feature branches are created off of master. We do run CI on them. That's these little like white arrows that you see here. And when you've got a green build and the work is completed, you go ahead and merge it back upstream. So the point that I really wanted to make here is that Git makes it really easy to isolate work in progress down on a feature branch basically that's code that hasn't been proven to be safe to release yet. And then CI makes it really easy to prove that the code is in fact safe and ready to ship. So that's why I think that the two are just really wonderfully powerful complementary technologies. Okay, so let's get down to the CI stuff. We're going to start with the repo, which is where continuous integration itself starts. So one of the things that you may have heard about Git is that you should avoid putting large files into your repository. So this is things like image libraries, pre-built binaries, things like that. And the reason is that when you make a local copy of Git on your local workstation, it's called cloning. So when you clone locally, Git clones the entire history of the repository. At least that's what it does by default. So if you have large files in there, you have to transfer all of those large files and every version of those large files across the network. So it makes the cloning operation rather slow. It eats up a lot of disk space, all that sort of thing. And removing those large files from your repository's history is kind of like performing brain surgery. It's very difficult to do, and usually people hire a consultant, a very expensive consultant, to do that. So the best thing is to just not put those files in your repo in the first place. So that's a good reason for avoiding the large files altogether. But if you're doing CI, and I hope you are, It's especially important because every time you run a build, your CI server has to clone the repository into the working build directory so it has a copy of your code. And if it's transferring all those large files across the network, it just slows down your build time. It means you get feedback to your developers slower than you would otherwise. But you might say, well, my build depends on all of these large files, all these pre-built binaries from the teams around me, so what do I do? Well, that is a very common situation. So what we found the best thing to do is to simply archive those files elsewhere. There are open source archiving systems like Nexus, Archiva, I think those are open source. There's proprietary systems like Artifactory, or if you don't want to do anything fancy, you can just, somebody's probably got a spare computer sitting under their desk that you could use, you can put on your network and use as like a temporary file storage location. So then, as far as your builds are concerned, you pull those into the working directory separately from, as a separate action from cloning the repository. So it's a lot like how you use Maven or Gradle to pull in third-party repositories at the top of your build. Next, let's talk about cloning. So as I mentioned, when Git clones a repository, the default behavior is to clone the entire history of the repo. Well, for CI, that's usually not necessary. And again, it just makes the build time longer. So you can use something called shallow clones on your CI system. And when you use a shallow clone, only the current snapshot of the repository is brought into the build directory. So that makes the operation quite a bit faster. It also eats up less disk space, so that's a bonus too. There is one exception, however. If you are doing something as part of your builds, like if you're doing a complex push back to the repository as part of your build, like say if you're merging two branches, you will need the entire history of the repository. The reason for that is that when Git is performing a merge, it needs the entire repo history to determine what the common ancestor of the two branches is. So shallow clones and automated merging don't mix. I'll talk a little bit more about automated merging in a minute, but I just wanted to just put that caveat in there. So if you are in a situation where shallow clones is not appropriate for your builds, a better bet is to cache the repo instead. And you cache them on your agents. And I realized that in Europe, probably not everybody is a fan of the TV show called The Americans, but they are these are secret agent spies. So perhaps the joke didn't work as well as I thought it would. But anyway, agents. Now, there's caveats to everything, right? So you have to keep in mind that if you are using, if you're doing a system where you are using like EC2 or some kind of cloud provider to spin up a build agent fresh with every build and then you destroy the agent afterwards, repository caching won't make any difference because of course you're going to be starting with a blank slate each time. So if you're using build agents that persist, if it's like a physical machine on your network, then repository caching can be quite useful. So it's another nice way to reduce the load on your CI system and speed up your build times at the same time. Okay, now the good stuff. Feature branching. Everyone loves feature branches. Let's see. What do I want to say here? Right, okay. So those of you who are already working with Git probably know that branches tend to live for a fairly short time. Because we use a branch per issue model, our branches tend to live for like an average of 3 days. It's fairly rare for them to live more than a week. So if you've got a branch that's going to be around for like 1 or 2 days, it's very tempting to be like, nah, I'm not going to run CI on this. I'll just run check style locally and that'll be fine. It's too much hassle to put CI on my branch. And it can be a lot of hassle. But nonetheless, it is really important to do continuous integration on all of your branches. Because if the first time that you run a CI build is when you merge to master, you get this horrible situation where master is broken, so you cannot release from master. you and your teammates cannot create new branches from master. And basically that defeats the entire purpose of using a branch and merge workflow in the first place. So you gotta prove out your code on the branch before you merge it upstream. So basically the way that you do this, that you get CI on your feature branch, is that you make a clone of all the build configurations that you're using against master, and then point those clones at your branch. But man, that's a drag. Nobody likes doing that. That's a lot of clicks, it's a lot of typing, it's bullshit. Let's not do that. So the new fashioned way is to make the computer do it for you. If you're using Jenkins, there's a plugin called the Build Per Branch plugin that will detect new branches in your repository, and when it finds one, it will automatically clone all your configs that you're running, your build configs for master, and point those clones at the new branch. It's very simple. But I do have to point out that that Build Per Branch plugin was, let's see, that came out about 6 months after we added that same functionality into Bamboo. So it's really just it's also not quite as robust, and I'll tell you a little bit more. I'll tell you why in a few minutes. Anyway, that's my plug for Bamboo. Right, so now we've got feature branching on, or sorry, CI on all of our feature branches. But we discovered one problem with this. We have 500, 600 maybe, what do you think, 600 developers maybe?
Are you talking to me?
Yeah.
Yeah, yes.
Okay, well 600.
I was waiting to see what was going to show up on the screen.
Sorry. Oh, I'm glad you were paying such close attention. So we have 600 developers, let's say, and each of them push changes to their feature branches several times a day. So now if every single commit is getting built, that's a lot of builds, and unless you can scale up your build agents like instantly and scale them infinitely, it's going to mean that your build queue just gets backed up. This is exactly what happened to us. We started using best practices like artifact passing to cut the build times down. We used we parallelized our tests, which cut the build times down even further, but still the build queue was getting backed up and our developers were waiting longer and longer and longer to get the test results that they needed. So just for example, on one of our Bamboo instances, we have, I think, 935 different build plans, and we plugged 140 build agents into that Bamboo instance, and then and did the artifact passing and test parallelization, and still, the build was getting clogged up. So we said, okay, we've got to find a better way to do this. But what we came up with, what we realized is that a reasonable way to balance, rigorous testing on one hand with conserving build resources on the other hand is to make the builds on feature branches have a manual trigger. So like they're just a push button. So it's up to the individual developer to decide which pushes or which commits they want to run those builds against. So it is a manual step in their process, but most of them find that they like the extra flexibility and control that gives them, because sometimes you make a push to the repo, but you know that it's going to break a bunch of tests, so like why bother running the test at that time? And you also know that you're going to do an hour's worth of work after lunch that's going to fix all those tests, so why not just conserve build resources and run the build once after you get back from lunch? But for builds on master or our stable version branches, well, in theory, the only time those branches are receiving commits is when it's a merge commit coming in from a feature branch. So, and besides that, these are the branches that we release from and that we create other branches from. So we felt it was really important to get feedback on pushes to those branches every single time and to get it as quickly as possible. So for that reason, we put an automatic trigger on those branches. So every push gets built, and because we're kind of conserving some build resources, those builds tend to not wait very long in the queue. Okay, so I want to shift gears a little bit and talk about an objection that I often hear when I'm talking about feature branching and continuous integration. And that is that it's not pure CI. And it's not. That's totally true. You don't have everybody piling all of their changes into a single location. But that's kind of the point, because like I said, when you're doing that, it makes that branch very unstable. However, pure continuous integration does have the advantage of giving you feedback very quickly, very immediately on how the changes, how the user story that you're working on interacts with the bug fix that your neighbor is working on. So the question is then, how do you sort of get the best of both worlds? How do you get rapid feedback about integration without completely destabilizing your entire code base? So I'm going to talk about 3 different ways that you can try. Each of our teams at Atlassian, like some teams do it one way, some teams do it another way. You can kind of try them out on your own well, not at home, at your office, and see what you like best. So the first is to rebase your branch against master. You might do this once a day. You might do this, certainly if you're going to do this, definitely do it right before you merge upstream. So for those of you who are unfamiliar with rebase, it resets the commit of origin for your branch and then replays all of the commits that you just made on top of that. So in animated form, it looks like that. So that's rebase. So this gives you rebasing your branch against master and then running continuous integration gives you a pretty good preview of how your code changes are going to interact with the code that's already on master. So it's a pretty good happy medium. You should only, and regardless of CI or not, don't rebase your branch if you are sharing that branch with other people, because then their local copy that they've cloned and what's now on a Git server on your sort of repository of origin is now completely different, and it's going to mess all kinds of things up for them, and they will be very cranky with you for making them go through the headache of untangling it. So rebase your own branch all you want, but just don't make your friends do it. Don't do it to your friends, that's not nice. Okay, so I mentioned automated merges before, and here's why you would want to do an automated merge. It gives you that sort of simulates a pure continuous integration workflow. So you can, and it offers a few advantages over rebasing. The first is that the repository history remains intact. So you're just merging your master down into your branch like once a day or maybe even every time you build. And that doesn't change the repository's history, whereas rebasing does. The second advantage is that you can completely automate this with your CI server. Bamboo supports the automation out of the box. I don't think that the Jenkins plugin does. But you can also add a simple script to your builds. Check out this branch, check out that branch, do the merge, and then continue with your build. And then the third advantage is that when you automate it, you also, so again, this is something that Bamboo will do out of the box, or you can script. But you can choose whether to use the merged CI run as just kind of an FYI, a preview, whatever, or you can opt to have the CI server actually push that merged code down to your feature branch, assuming all the tests pass. You could actually even choose to have the CI server push the merged code upstream so that your teammates can get a hold of the code that you've been working on. So if you're working on something that other people around you are dependent on, you can use automated merging in your builds as a way of sharing that code with your team so that you're not a bottleneck for them. But here again, there's a caveat. So I just want to remind you of what I said about shallow clones before. Shallow clones and automated merging don't mix. So if you're going to do automated merging as part of your builds, cache the repo on your agents instead. Right, so this is how it looks in Bamboo. You go to branch configuration, you check a box that says, yes, please merge my branches. You select the 2 branches that you want to merge. And then at build time, Bamboo checks out both branches, merges them together, runs CI on the merged code, and then gives you the results. And again, if all the tests pass, you can opt to have it actually push that code to one branch or the other. So it's a really nice way of making sure that not only that you're getting feedback about how your changes play with your teammates' changes, it also helps ensure that your branch doesn't drift very far away from master, and it makes that final merge back upstream much less painful. And the third way is to use a shared integration branch in your team. This is kind of like the Git flow way of doing it. So you've got your feature branch running alongside master, and then you also have this integration branch here, which just sort of persists forever and ever and ever. And the workflow, what the workflow looks like is, you do some work down on your branch, and then when you've got a clean CI build here, you can merge that up to integration. And it will probably cause some test failures the first time. So, no problem. That's actually really good information to get, that your changes don't play well with my changes. So you go back to your feature branch, resolve those conflicts, and then sort of rinse and repeat that cycle until you have a green build on both your feature branch and on the integration branch. And at that point, you can then, that it's safe to merge your feature branch up to master. And I do recommend merging your feature branch to master. Don't merge integration upstream, because that integration branch is likely to contain, half of a user story or half of a bug fix or something that's just not ready to be on master yet. So I think it's best to keep the work very isolated and sort of modularized. So go back to your feature branch and merge up. Okay, so Git hooks. Who knows what Git hooks are? Okay, about half the audience, that's great. So for the rest of you, you'll learn something, yay! So Git hooks are kind of like Git's plugin system. You can use them to, you can attach them to certain operations to either, the hook will run some sort of script or perform some sort of function either before the operation completes or afterwards. So you can think of it as like hooks can function as a bodyguard for your code base. And if the script fails, it says, no, I reject this operation. Or it can also be sort of your taskmaster. After the operation completes, the hook script can carry out some additional functions for you. So the .git directory comes with a directory called hooks. So you can look that up as soon as you're back at a computer. And inside that inside the hooks directory, there's a few sample scripts that sort of show you what's possible. So there's the pre-receive hooks and the post-receive hooks. So the pre-receive hooks are kind of like those bodyguards that I mentioned, because they have the option to cancel the operation. The post-receive hooks, again, are your taskmaster, your minion, if you will. And then the other two ways that you classify hooks are client-side and server-side. So client-side, as you would expect, they live on your local machine. You can check the hook into the repository, but when you clone a repo locally, you won't get the hooks. You won't get your teammates' hooks along with them. So the client-side hooks are very customized to just your workstation. And then the server-side hooks, not surprisingly, live on your Git server. So you can do things like a pre-receive, like a pre-commit hook on the client side could run check style for you before the commit is actually processed. And if there's just bad, critical or blocker violation, check style violations, it can reject that commit, and then you can fix those up and then try the commit again. Also on the client side, I talked about how archiving large files is a good idea, or at least not keeping them in your repo, right? So if you were checking out a new branch to work on, you could have a client-side hook that goes and fetches those files, those other files that you need to work with, and brings those into your workspace so that you don't have to think about what you're doing. It's just done for you, and you never forget that one file, right? And then on the server side, the pre-receive hooks are really powerful for CI, and I'm going to go deeper into those in a moment. And then the post-receive server-side hooks can do things like send a message out to your team's chat room whenever there's a push, or perhaps when a pull request is created. It's really nice for notifications. So, like I said, the pre-receive server-side hooks, I think, are what gives your CI system or your code base sort of like a ninja guardian around it. Developers in general, and I'm sure all of you in this room, are generally pretty good about not making a merge into master when there are broken tests down in your feature branch. But sometimes we forget to check. And sometimes we're sharing a branch with other people, and there may be some tests that broke that we're not aware of. So that's where your Ninja Guardian comes in. One of my colleagues, Tim Pedersen, he's one of our developer advocates at Atlassian, wrote a script, a hook script, that listens for incoming merges to master, and when it finds one, it will check the branch it'll look at what branch is being merged in, and then it calls out to the CI server to see if the latest build on that branch is passing or failing. If it's passing, the merge is processed. If the latest build on the branch fails, then the merge is rejected, and you have to go back and fix it up, whatever, and then retry the merge. So that's a pretty slick one. The other one that he wrote has to do with code coverage. Who here tracks code coverage? Okay, yeah, not everybody, but I'm glad to see that some people do. So, as you are probably well aware, code coverage it's a battle every day, man. You start with a really low number, and then you add tests to your code base, and you get that number just a little bit higher, and maybe you finally get it to a place where you're satisfied with your level of code coverage, and you've worked so hard for it. And it's really frustrating to see that number then slip bit by bit as you or your teammates add application code to the repository without the proper tests to back that up. So Tim wrote this cool hook, which is maybe a little heavy-handed, but it's still kind of cool. It's also a pre-received server-side hook. It listens again for merges coming into master or a stable version branch, and when it finds one, it again calls out to the CI server and checks the code coverage statistic for your branch, checks the code coverage statistic for master, and if the coverage on your branch is worse than master, it rejects that merge. So, like I said, it's a little heavy-handed. It's a pretty big enforcement mechanism, but code coverage, like if you're really concerned about code coverage and serious about it, it might be worth it, because like I said, it is a battle that you have to fight every day. It takes a lot of discipline. So both of those hooks are available in a repository on Bitbucket. I guess this is being recorded, so you can go back and look at the recording if you don't have a pen to write it on your hand. But those two hooks are in that repository, and I think there's a couple others in there as well. All right, so I'm going to wrap this up. You've been great listeners, and I can't believe you're standing this whole time. Oh my God. Yeah, mine too. So the 5 things that I really want you to walk away with here are, first of all, to take advantage of feature branching. It's a really slick way to keep dirty code or code that you're just not sure is clean, keep it off master and keep master very clean. So do use those. Shallow cloning and repository caching are nice little tricks to make your CI server and your repository sort of work hand in hand better, and it speeds up your builds, and it takes some load off your CI system at the same time. Definitely do run CI on all your feature branches and use automation to make that happen, so that you don't have to click, because it's boring, and you're not getting paid to do boring work. We didn't talk about this so much, I kind of skipped over this. I did talk a little bit about sharing build resources, so think about whether or not you really need to run each commit on your feature branch, and maybe the answer is yes, and if so, that's cool. It's just something that I want you to think about. And then finally, Git hooks give you ninja powers to protect master and create sort of a fortress around it. So I'll leave you with a couple of free things, because everybody loves free stuff. Whether you're new to Git or you're a total Git guru, check out SourceTree if you haven't. It's a free little app for Mac and Windows. It's a GUI client for Git, and if you like me have a hard time remembering all the exact syntax of all those commands, or if you simply prefer to push a button instead of type things at the terminal, SourceTree is really helpful. And the commit graph on it, I think, is just so slick. It's super helpful. And the other thing is our Git microsite, Atlassian.com/Git. If you're new to Git, it's got tutorials on most of the Git commands, at least the most used ones. It talks about a number of different workflows, including the ones I've talked about here. And if you are not new to Git, and you're, again, a Git guru, and if you want to get really deep into like when you would use re, or how to manage a large repo, or what's new in Git 2.1.19, the article section in the Git microsite will have some good stuff for you. So check that out. Both of those are totally free. And I don't know if do we have a little time for Q&A? I think I've already gone like almost 40 minutes. Questions?
Depends if there are questions at all.
Okay.
When you pointed out the integration workflow with the integration branch, you said that the breaking and build on the integration branch will trigger work on my own feature branch. But I didn't see going arrows back and forth, because if the build breaks, I probably will have to pull some changes from the integration branch back.
That's a good point. You may have to do that. Yeah. I mean, I guess it kind of depends on the nature of the breakage.
Yeah.
But that's a great point. Thank you for bringing that up.
Is the integration branch shared among the team?
Yes.
Okay.
Yeah.
So how do you make sure that if I push something there and I see it breaks and a colleague of mine does the same and I go back to my feature branch to fix it, I have a half user story of someone else there.
Well, if you pull
how
code,
can I ever have a working integration branch?
so you'll have half a user story on your feature branch if you pull code from integration down to your feature branch. So that's, again, it's kind of a case-by-case basis. You may want to take on that additional code, or you might look at the breakage and think, oh, okay, I know what I have to fix. I can just go do this, isolated down on my branch. So I'm not saying that this is. That's the integration branch is where all the mess happens. Like, right? I mean that. Whenever you're integrating code changes from multiple people together, there is going to be some mess. I'm not really sure how you avoid that entirely. The question is, do you want to deal with that mess on master, where you're trying to release from, or do you want to deal with it before you get to master? And usually teams say, before is better.
Yeah, I would say I would have tried to fix the problems in the integration branch. Of course, then I blocked the integration branch until I'm done. And then it's green again.
Right.
But then no one else interferes with me and makes my work more difficult than it has to be.
That's true. There's some coordination amongst the team that's required.
And that's how we do.
Yep. And if you're working with a large team, if you've got 10, 12 developers, that integration branch workflow might not be the best one. I think that workflow works better when you have a team of, something more like 3 to 5 people. It's a little bit less messy.
Especially if you're not working with co-located teams, that's the mess.
Oh yeah, I didn't even think about that.
We did that.
They're asleep. Damn it. Any other questions before I turn it over to Joe?
You mentioned the auto branching feature in Bamboo. Does it work with a Bitbucket?
Does it work against a Bitbucket repository?
Yeah.
Yes, it does. So the ability.
Something wrong.
Oh, okay. Okay, well we can talk then. Cool. Well, thanks so much. I'm going to turn it over to Joe.